Write the IUPAC names for these alkanes. First thing that we have to do in order to determine the name is to find the longest continuous carbon chain. It can be going horizontally, vertically. We just have to make sure that it is continuous. So for example, in this molecule, what kind of chains can we look? So for example, if I go this way, it's 1, 2, 3. I could also go this way, 1, 2, 3, 4, 5. So this is the longest continuous chain. Let's go ahead and highlight it. The next thing that we have to do is we have to number from the end that is closest to the first substituent. Substituents are groups that are coming off of the parent chain. So this is our substituent group. And the end of the chain that is closest to this group must be here. So I'm going to go ahead and number 1, 2, 3, 4, and 5. Next, I just have to name the substituent. The way we name substituents is we have to say the number of what carbon the substituent is attached to. So here it is attached to carbon number 2. And then we have to say the name of our substituent. One carbon, that is called methyl. Now we have to put it together. We have first substituents and then the parent chain. The name of the parent chain is 1, 2, 3, 4, 5. We have 5 carbons. So the prefix for 5 carbons is pent. And because it's all single bonds, we have to say ane. So we say pentane. So our prefix is pent, signifying that we have 5 carbons in our parent chain, and ane signifies that it's all single bonds. Next, we just have to put the substituent in front of it. So this is 2-methyl pentane. And let's go to part B. Again, the first thing that we have to do is we have to find the longest continuous parent chain. So I can go like this, 1, 2, 3 again, or I can go 1, 2, 3, 4, 5, 6, or I could go 1, 2, 3, 4, 5, 6. Now these are equal, so it doesn't matter which way I choose. So I'm just going to go ahead and choose the horizontal one. And the next thing I have to do is I have to number it. There are 2 substituents coming off of my chain, here and here. And again, I number closest to the first substituent, but you can see that they're the same substituents and they're equivalent to both ends. So this one would be on carbon number 2 and this one would be on carbon number 2. So it doesn't really matter where I begin. So I'm going to begin here again. And I'm going to number 1, 2, 3, 4, 5, and 6. Since I have 6 carbons, the prefix for 6 carbons is hex. And again, because it's all single bonds, and all of this will be single bonds since we're dealing with alkanes, this is hexane. Next, let's name our substituents. Again, we start by identifying to which carbon our substituent is attached. So this one is attached to carbon number 2. And again, it's 1 carbon. 1 carbon has the prefix meth. And as a substituent, it has to end in -il. So this is 2-methyl. And this is the same substituent, so it's methyl group again, but it's on carbon number 5. When we have 2 or more substituents together with the same name, for example, both of them are methyls, we have to combine them. So instead of saying 2-methyl and 5-methyl, what we do is we will say 2, 5 dimethyl. Di means 2. So this signifies that there are 2 methyl groups on carbon number 2 and on carbon number 5. Now let's go to part C. Again, let's look at our longest chain. And our longest chain will be this one. And again, we could have one this way. It would have been fine because it's the same number of carbons. And the next thing we do is we see that this is our substituent. And we have to number from the end closest to it, which must be this end. 1, 2, 3, 4, 5, 6, 7, 8. 8 is oct. The prefix for 8 carbons is oct. And because we know it's all single bonds, it's octane. Now, what is the name of the substituents? It's attached to carbon 3, so this is 3. And there are 2 carbons here. The prefix for 2 carbons is eth. Eth. And since it's a substituent, we have to end it in -eel. 3-ethyl. 3-ethyl octane. And now let's go to part D. Again, what is our longest chain? Our longest chain will be this one, the horizontal one. So we will go like this. And you can try numbering different chains to see which one is the longest. So we can go 1, 2, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So if we would have run this way or this way, that would have been fine as well. I just chose the horizontal chain. And what we do next is we're going to number from the end closest to the first substituent. Now in this case, on the left, I have 3 substituents, this one, and this one. And on the left, I have 1 methyl group on the second carbon. From the right, I would have 2 methyl groups on the second carbon. So what is better? This is better because more of my groups get the lowest number. So I'm going to start numbering from the right. 1, 2, 3, 4, 5, and 6. There's 6 carbons in my parent's chain. The prefix for 6 carbons is hex, and it's hexane because it's all single bonds. Next, let's take care of the substituents. This methyl group is on carbon number 5, 5-methyl. And there are 2 methyl groups on carbon number 4. 2-methyl and 2-methyl. And again, like we said before, when we have multiple substituents with the same name, we have to combine them. So instead of saying 5-methyl, 2-methyl, and 2-methyl, what we're going to write instead will be 2, 2, 5, tri, because we have 3 tri-methyl hexane. And this tells us that there is a methyl group on carbon number 2, another methyl group on carbon number 2, and a methyl group on number 5. This is Maya Lochi from Transformation Tutoring, and I really hope that you enjoyed this video.